Here we're going to look at some examples of hypothesis tests for a population proportion P. I'm not going to go through great detail in every question. I will have you read the question, pause the video, and then show you the answer, just for the sake of time. But remember, the hypothesis tests for P are exactly the same concept as any other hypothesis test for mu, except the difference is our test statistic is z equals, instead of x bar minus mu, it's p hat minus p. And then you divide by the standard deviation of our sampling distribution for p hat, or for p, which is the square root of p times q over n. So that's our test statistic that we're using, rather than z equals x bar minus mu over sigma over square root of n. We're using this, but it's the same concept. Okay, so you set up your hypotheses, sketch your rejection region, calculate your test statistic, and then make your decision. Okay, so read the first one, and in a few seconds I'll put up the answer, and I'll mention a few things along the way. Okay, so here's the first one. Professor claims 15% would report a cheater. So P equals 0.15, and that was the claim. Okay, he claimed that, or that professor claimed that 15% would report a cheater. So the alternative is P not equal to 0.15. So you have a two-tailed test. And with a two-tailed test with a 5% level of significance, or alpha is 0.05, gives you plus or minus 1.96. So here we end up with a test statistic of negative 0.396, which is very close to the center. So if the population proportion really was 0.15 or 15%, if that were true, then getting this proportion of 28 over 200, which is 0.14 or 14%, is not too far away from 0.15 to say that that 0.15 was a bad assumption. So here we failed to reject HO, and there's not enough evidence to reject the claim that 15% of all students would report a cheater. Okay, number two. Okay, read that and I'll show you the answer. Okay, so here they asked 1,000 people. 435 said they would support challenging the results. So there's your hypotheses. This one with the wording, a minority of people is less than 50%. So P is less than 0.5. That's your claim for the alternative hypothesis. And your null will be that P equals 0.5. So if you didn't get that part, pause the video and go back and redo it. But I'm going to show you the rest of the answer here. Our rejection region, using a 1% level significance, so alpha is 0.01. A left tail test gives us a z star value of negative 2.33. And then there's your test statistic, negative 4.11. And that's a very, or fairly extreme value, negative 4.11. That's way out to the left here. So our decision is to reject the null hypothesis. And there's enough evidence to support the claim that the minority of those support a recount. And then on the next page, this is just giving you data in a different way. So this goes back to the example, the female and male Republicans asked whether they support an initiative by the candidate. So in part A, is the proportion of all male Republicans who support the initiative less than 2/3? Okay, so again, pause the video and I'll go over the answer here. Okay, so P is less than 2/3, that's the claim, so there's the alternative, because of less than 2/3. P equals 2/3 will be the null. With alpha 0.05 with a left-tailed test, gives you a Z star value of negative 1.645, so there's your rejection region. Calculate your test statistic. Okay, so 96 out of 150 support of a male Republicans support the initiative. So where that fraction, 96 out of 150, comes for P hat, there's 96 males that said yes, out of a total of 150 males. That's 96 plus 50 plus 4. Because all they're looking at here are the male Republicans. So the females don't matter for this question. Okay, and I just want to be clear that do not put 2/3 as 0.67 or 0.667 or anything like that. Leave it as 2/3. Otherwise, you could have some real round off issues. Okay, so just put that fraction in your calculator, and you end up with a Z test statistic of negative 0.69, which is right about here. So our decision is to fail to reject HO, and there's not evidence to support the claim that the proportion of males who support the initiative is less than 2/3. Okay, there's not evidence to support that claim. Because if you fail to reject HO, you're saying HO is good, so you cannot support the alternative. Okay, and then in part B, what is the p-value for the test statistic in part A? Well, the p-value, now we're looking at the probability of getting a test statistic as extreme as negative 0.69. Okay, so the probability of your p hat being less than 96 over 150. So the probability of getting a sample proportion as extreme as 96 over 150. We converted that to a Z-score, basically by finding the test statistic. So the probability that your test statistic was as extreme as negative 0.69, you look up negative 0.69 in your Z table, and you get 0.2451. So what is that? How does that relate to our decision? Well, 0.2451 is a pretty large p-value. Remember that small p-values lead you to reject the null hypothesis, because that means that you're way out on the extreme end. A small p-value means a small probability. Well, a large p-value or larger probability leads us to fail to reject the null hypothesis. And that's the decision that we made up here. And then finally, part C, a campaign staffer claims 45% of all Republicans say no to the initiative. Test the claim at 0.05 significance level. So now we're looking at 45% of all Republicans saying no. So now we're testing that claim for all Republicans. So now when we look at our number of Republicans that say no, there were 110 total no's out of 285. Okay, so the 110 no's out of 285. Our hypotheses, P equals 0.45 and P not equal to 0.45. Okay, now the claim is the null hypothesis in this case because the staffer is claiming that 45% said no. So that's your claim, the null hypothesis. So our rejection region, we have 5% significance level is split between two ends. So that gives you plus or minus 1.96 for the Z value here. Okay, so our test statistic, when you calculate that, you end up with negative 2.17. And that is just to the left of this end here, the left end. So that leads us to reject the null hypothesis, and there's enough evidence to reject the claim that P equals 0.45.